Hello, my name is Leanne Giannis and my partners are Madison Carter and Kelly Delgado. Today we're going to be talking about life on Mars. So our goal of the study is to determine the possibility of plant life on another planet than just Mars. For this to happen, we will have to do a study on a genetically modified plant that can trap carbon dioxide. So our main reason for relocation to Mars would be a lack of resources, which could be either a lack of land or a lack of elements. For example, lack of land would be overpopulation in agriculture, and a lack of elements would be elements that Mars has that are also on Earth, such as iron, aluminum, magnesium, and potassium. So before we enter this topic a little bit more, we have to determine some of the plant necessities under certain conditions such as Mars. So plants we know need light, air, nutrients, and water. And we know as for Mars's atmosphere and composition, it's about 95% carbon dioxide, 78% nitrogen, and 21% oxygen. Excuse me. So then we would next determine the soil on both Earth and Mars. So for Earth, we know for Mars, we know already, according to NASA, that they do have certain nutrients needed in order for plant growth.
So next we're going to be talking about measuring data to solve the problem. This includes plants' basic necessities as light, air, water, and nutrients, and we're going to measure the plant life in the biodome. The time we grow it, and to see how long it grows, and to see how long it lives before eventually dying out. What did I do? Oh my god. Sorry. Next I'm going to talk about methods and techniques. So first things first, you have to verify that this experiment has not been tested. If it has, then there is no point in conducting another experiment. Second, we're going to confer with a natural heritage botanist, which is just a scientist who studies plants and anything it takes to grow them, to correctly modify them, anything in that nature. And then you're going to refer with a statistician that will tell you the experimental population of plants, the statistics of plants and the growth of that. And then you're going to conduct experiments on Earth after you have taken samples from Mars, which is the soil. We're planning on traveling to Mars and collecting a sample of the soil and testing it back on Earth to see how long it's capable of living, and if it all goes well, then we go back to Mars and finish off the experiment in the biodome over there.
So, what are we doing? Well, we're going to be modifying wheat so that we can increase the intake of carbon and be able to grow in decreased temperatures. And when it's in Mars, we're going to customize irrigation systems so that from the flowing waters on Mars. A quick history on biodomes. We currently have a biodome that can't quite support human life. It was only able to support humans for approximately a year, but it can support plants, and currently the plants are thriving. But the researchers on the biodome are still trying to get the biodome up to par to support humans. Eventually, when they do get it to support humans, we will use the biodome on Earth so that we could support the agriculturalist and botanist on Mars. Some research ethics on plants. These make sure that plants are not rare, or if you do use rare plants, you don't use all of them, all the rare plants, so that they don't go extinct. However, in this experiment, we'll be using wheat, so this wouldn't be too much of a problem. We will need botanists and plant engineers to consult with and be sure that these plants are able to we are able to do what we wanted to do, and we have to make sure that it's safe for consumption. Therefore, we will have to use tests on rats. Some ethics on animals. The Animal Welfare Act, passed in 1966, ensures the safety and rights of animals. Rights like basic necessities, i.e. food, water, comfortable shelter, etc. And it also protects animals from unnecessary harm and death. Some relevance as to why we need to do this. It's for when we run out of arable land, land that we can grow plants and harvest food, or we could use it to mine some for iron and aluminum and stuff like that. This research will also produce new technologies such as a newer and updated version of the biodome that is able to support human life and animal life. We will also be creating genetically modified plants that can grow at low temperatures, like Mars, which reaches negative 80 degrees. And we will also customize irrigation systems that is specific to Mars, so that the plants can grow and thrive. So that is our presentation on whether we can have life on Mars.